MongoDB has consistently been ranked as one of the top 5 NoSQL database management systems. So if you're someone who's applying for a position in database management roles, you will almost certainly be working with MongoDB at some point. Now, whether you're upgrading your skills or interviewing for a database management position using MongoDB, it's a good idea to be familiar with the most frequently asked MongoDB interview questions and answers. In the latter case, it is beneficial for you to prepare for the interview so that you're not caught off guard. Even if you're just interested in learning about MongoDB for the sake of upskilling, keep in mind that acquiring this kind of knowledge may lead you to looking for a better job, which means you'll be facing an interview sooner. On that note, hey everyone, welcome to SimpliCode's YouTube channel. I hope you guys are doing good and staying safe. In this tutorial, we'll be discussing some specially curated MongoDB interview questions that you must master to crack your next interview. So without any further ado, let's get started with today's topic. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So let's get started with today's tutorial. So firstly, let us discuss the agenda. Now this MongoDB interview question is intended to give you a general idea of the types of interview questions you might face. Now we'll be covering some theoretical as well as practical questions in this tutorial. Now typically, recruiters begin with simple questions and gradually increase the difficulty level. So in this MongoDB interview questions tutorial, we'll start with the basics and then progress to more complex questions. Now before we begin with the types of questions that are being asked, here's a simple and quick tip for everyone who's watching this video. Now make sure you have the never give up attitude. I know it's that time of the year where placements are going in a rampant way, and I know you might be giving interviews regularly. And what if you didn't get an offer in one of the interviews from that? So make sure you have that attitude of never give up and prepare for your next interview. And whenever you're giving an interview, make sure you are interactive. Being interactive is one of the best way you can say in order to get hired by the recruiter. So make sure you're conversing properly with the interviewer while asking the questions. And finally, behave professionally, which is another key aspect while giving an interview. So let us now discuss the first question, which is the basic question which will be asked, which is explain what is MongoDB and its features. So this is how you can answer. MongoDB is basically an open source cross-platform NoSQL document-oriented database management system. Now, NoSQL can be utilized as a substitute for traditional relational databases like SQL and MySQL, which is dependent on the SQL language, right? So if you want to work with large data sets of distributed data, then NoSQL databases may be quite supportive, which are used to store large volumes of data in the form of documents, which will offer the developers the flexibility to work with the evolving data models as there is no fixed schema in this. Now, relational databases such as MySQL and Oracle store data in tables and rows, right? They are based on a branch of a theory known as relational databases. Now, these relational databases are structured and tables can be linked with each other via a foreign key, which is a property of relational database, which is ACID property, which is being satisfied by the relational database. But whereas the MongoDB being a documented oriented database, it can handle only that sort of information and store as well as retrieve information from these documents only. It provides the flexibility as well as scalability that you want with the querying and indexing according to your requirement. This MongoDB basically is based on JSON-like documents where we store all the information in that. So this is how you can answer the question, which is what is MongoDB and its features. Well, the next question is, what are some alternative NoSQL databases to MongoDB? Now we have various alternatives from MongoDB such as Cassandra. Apache Cassandra is a free and open source distributed NoSQL database management system, which is again similar to that of MongoDB to handle large amounts of unstructured data across the servers, providing high availability with no single point of failure. Apache Cassandra is a database which can be a right choice when you need scalability and also high availability without compromising performance. Next, we have Redis. Redis is actually another popular NoSQL database, which is an open source, which is implemented as a distributed key value store with optional durability. It can be also used as a cache and a message broker. Also, we have other popular NoSQL databases like Amazon DynamoDB, Apache HBase, and Neo4j. Now, HBase again is an open source non-relational distributed database, guys. It is generally written in JavaScript and it is also developed as part of the Apache Software Foundation. So these are some of the examples and can be used in alternative to MongoDB. Alright, let us now move to the next question, which is what type of NoSQL database is MongoDB? Now, in general, we have 4 different types of categories when we talk about in which category MongoDB comes under. So basically, we have key value, column-based, document database, and graph database. Now, when I talk about key value, these databases store data as an index key and value pairs. These databases store data in a schema-less way. Example of key value data store include Cassandra, Redis, DynamoDB, and etc. Next, we have column-based. Now, column-based or column store type of database is the one where these databases are designed to store data as columns of data rather than as rows as data. If it stores in a row type of data, again, it becomes a traditional, which is not a NoSQL database, right? So again, example of a column store databases are HBase, even Cassandra comes under the column-based as well. Next, we have the document database, which is actually the type of NoSQL database that we are looking for, which is MongoDB. Now, document databases are designed to store documents with each document having a unique key. And popular document databases are Couchbase and MongoDB. And finally, we also have a graph type of database where they are based on graph theory. So these databases are basically designed for data which needs to be represented as graphs. So the data that is present in this sort of database is interconnected with multiple number of relationship between them in the form of graphs and trees. And a popular graph database is Neo4j as well as big data. So this is what MongoDB is, and it comes under the document database type of NoSQL database. The next question is, how does MongoDB store data? Now, data in MongoDB is stored in JSON documents or the JSON style data structures. Documents contain one or more fields, and each field contains a value of a specific data type. So MongoDB stores data records as documents, which are in the form of JSON documents, which are gathered together in collections. So these documents, as we said earlier, has a sub-specific data types, including, let's say, arrays, normal general data, and these documents tend to share a similar structure, which are organized as collections. So you can say a group of documents are kept in a collection. It may be helpful to think of documents as in a comparison to the rows in a relational database. So fields are similar to columns and collections are similar to tables in MySQL database, which is again it's a relational database. So this is how MongoDB stores data. The next question is, MongoDB is a schema-less database. If yes, how do you create schema in MongoDB? Now, the schema of a database describes the structure of the data to be stored, right? In a relational database, the schema defines its tables, its fields in each table, and the relationship between each field and each table. So if you take SQL as an example, which is a schema-based database, right? So its schema is defined by the tables and the fields, that is the columns and rows that are present in it, and the relation between them. On the other hand, we have MongoDB. Now, in documented-oriented databases like MongoDB, data is stored in collections of key value pairs. Now, given that JSON is a schema-free data structure and that MongoDB depends on it, it would be more accurate to say that it has a dynamically typed data. So whenever you create an inserted document to create a schema, it will automatically create one for you. So whenever a document is added, the database will automatically create the corresponding collection. The next question is, how is MongoDB different from SQL and better than MySQL? Now, MongoDB is again a documented-oriented NoSQL database which is used to store high volume of data and which needs to process huge data in a quick session. Now, it is a database that came into picture around the mid-2000s, and it is again considered into the category of a NoSQL database. Whereas when you take SQL, SQL is a programming language used to communicate with and manipulate relational databases. For example, MySQL. Now, there are quite differences between both of these databases, right? Being one as a relational database, the other being relational and non-relational database. there are quite differences between them. So for example, if you take the structure, in SQL, data is represented in tables, whereas the data is represented in documents, and this further documents are stored in collections. Now schema, again, SQL has a predefined schema. So whenever you're creating a table, you need to predefine its schema, whereas MongoDB does not have the implications of specifying any schema before working on it. So it has basically a dynamic schema. Next, we have this scalability. The data in SQL can be vertically scalable, and when it comes to MongoDB, both horizontal and vertical scaling of data is possible. When I talk about transactions, SQL also supports atomic operations and follows ACID properties, whereas MongoDB does not have proper support for transactions and it follows CAP theorem. And finally, the type of operations. Now, some operations that we perform in relational databases like SQL, for example, SQL supports join operation, whereas we don't have the same sort of join operation in MongoDB. So in this way, MongoDB is different from SQL, and in some ways it is better than MySQL in terms of processing a lot of unstructured data, and also has certain features like replication, sharding, and map reduce, and some of more critical features that are not present in MySQL. Well, the next question is, what are the different data models in MongoDB? Now, data models are categorized into two types. The first one is embedded data model. The next one is referent data model. Now, if I talk about embedded data model, embedded documents capture relationship between data by storing related data in a single document structure. Whereas reference data model store the relationship between data by including any links or references from one document to another. Moving on to the next question. The next question is, how does indexing works in MongoDB? Now, a good indexing strategy, be it a relational database or a NoSQL database, it is essential for ensuring that your database returns your results as quickly as possible. Now, MongoDB indexing is a special data structure on which the index is created to hold the data of a specific fields in a document. Now, in the absence of indexing in MongoDB, there is a need to scan every collection, which is basically a collection scan. So MongoDB indexes make it unnecessary to perform a collection scan, which involves looking through every document in collection for matches to your query. It also provides effective indexing strategy. Now, any collection in MongoDB can have one or more indexes, and those indexes can be made on one or more multiple fields and even throughout a MongoDB database. So you need a good indexing strategy to quickly and, let's say, effectively access the data you require from it. And it also provides search efficiency. Now, indexing is a necessary operation in MongoDB, which will bring search efficiency in various execution of statements. So this is how indexing works in MongoDB. So moving on to the next question, what is MongoDB replication and sharding? Now, if I talk about replication, replication means duplicating the same data across multiple MongoDB servers. So the main use of replication is the data is available at an instant way, that is high availability of data, and it also supports data redundancy. And multiple copies of the data are being saved across servers. And also it provides data recovery and backup options as well. So in a nutshell, you can say that database replication is the process of copying data from one database in one server to another database in another server, ensuring that the same data is available on more than one MongoDB server. So again, the main purpose of using replication is data redundancy and high availability. So by keeping data several copies or replicas stored on physically separate servers, it will ensure that the data is protected and it is also accessible whenever we need. And also by generating multiple copies of your data, replication enables you to increase data availability, which is also another important factor. This is especially helpful if a server fails. So in that case, you can use the replication. And finally, you can also recover the data that is lost due to any uninterrupted or any hardware failure issues. Now, if I talk about sharding, sharding is also similar to that of replication, but it is a method of distributing data across multiple databases. And MongoDB supports this deployment of data with having large data sets and high throughput via sharding. So let's take an example. So you can give an example to the recruiter like this. Let's say I have a database having 2 million users and it has a capacity which is 2 million records. Now what I'm doing is I'm basically distributing the data across multiple databases and I'm storing different data in different databases. Now we have two machines which has 1 million user capacity and another 1 million user capacity. So in this way you can add more and more multiple databases in order to store your data. So by adding more capacity to a single server, such as adding more memory and processing units or adding more RAM on a single server, that can be done using sharding. Let us now move on to the next question, which is explain horizontal and vertical scaling. Now, vertical scaling refers to adding more resources like CPU, RAM, or any hardware or hard drive disk space to your server, which is again a database or an application server, which is done on demand. On the other hand, horizontal scaling refers or involves adding more processing units or physical machines to your server or databases. Now, MongoDB, which is a NoSQL database, handles horizontal scaling through sharding. So in a nutshell, you can say that vertical scaling can be used in order to increase or decrease the capacity of existing services, whereas horizontal scaling adds more resources like virtual machines to your system to spread out the workload across them. The next question is, when should we embed one document with another? So you should consider embedded document, that is sub-document, whenever you rely on these four factors. That is, when the relationship is one to few, that is, it can be one to many, but not one to one. So for unlimited use case, you should start considering separating sub-documents into another collection. The next situation is when retrieval is likely to happen together, which will improve the performance. In such case, you can embed one document with another. The next factor is when updates are likely to happen at the same time, you can use this multi-document transaction by embedding data model. And finally, when the field is rarely updated, in such case, you can use the embedded document. Well, let us now move on to the next question, which is what are replica sets, and explain primary and secondary replica sets. In MongoDB, the process of replication, as we discussed earlier, is done via using replica sets. In simple words, it is a group of MongoDB processes to keep the same data across different servers. Now, a replica set is basically a collection of related MongoDB nodes, which must have 3 nodes at least. Now, one of them must be a primary and the rest secondary ones. And a replication structure can have up to 50 nodes. So the main types of nodes that we have is primary and the secondary, or you can call them as primary and secondary replica sets. Now, when I talk about primary replica set, it is the primary is the member in the replica set that receives the write and read operations. But read operations can be pointed out to secondary nodes, changing the configuration at the moment to perform the query. Besides, the replica set can have only one primary node at most. And talking about secondary, the secondary is the node where the data is replicated to maintain a copy. A replica set can have one or more secondary nodes, and the clients cannot write data to secondary ones, only they can read from them. And if at all there is any failed node, it works as a secondary node again until a new primary node will be replaced with that. So this is what a replica set means, and the type of replica set, which is the primary and secondary. I hope you understood this. So moving on to the next question, which is what is the use of capped collections? Now the size of collection in MongoDB is typically unrestricted, right? So the collection increases its size as more documents are being added to that. Now a capped collection is a special type of collection that has either a fixed number of documents in a collection or fixed number of elements. So it creates new documents by overriding the oldest documents present in that collection. So capped collections can have maximum size or document counts that prevent them from growing beyond the maximum threshold that is being allocated. And all capped collections must specify a maximum size and may also specify a maximum document count only. Now, MongoDB removes older documents if a collection reaches the maximum size limit before it reaches the maximum document count. So overall, the structure and functionality of a capped collection supports high performance for CRUD operations like create, read, and delete. So this is what capped collections is and some of its characteristics and why we use it. Let us now move on to the next question, which is how can you store images, videos, and other large files? Now, we often need to store files in our databases, but MongoDB sometimes, or it doesn't let you store any file larger than 16 MB in a normal document. So what you have to do? Instead, MongoDB has a functionality specifically for storing large files, and it goes by the name GridFS. Yes, you have heard it right. GridFS is a driver specification for uploading and retrieval of MongoDB files which are larger than 16 MB in order to store images, videos, and other large files. It is one of the most popular specifications, and it has a size limit of more than 16 MB. So you can store images, videos that have size more than of 16 MB. Now, chunks of files, like be it an audio, be it a PDF file or anything, it is being streamed as a chunks. So these are streamed into the database, and each chunk is limited to 255 KB in the size. This means that the last chunk is normally either equal to or less than 255 KB. So whenever you read from GridFS, the driver resembles all the chunks as needed. This means that you can read sections of a file as per your query range. So I hope you understood what is GridFS and what is the process to store images, videos, and other large files which is of more than 16 MB. So basically the interviewer want to know that whether you are not familiar with the concept of GridFS. So that is the reason he might ask you this question. So you have to be well prepared for it. Well, the next question is explain aggregation in MongoDB. MongoDB aggregation processes the data records during an aggregation operation and returns a single computed result. Just like any other operations that are performed in a relational database, similar to that, aggregation is also used in order to act on a group of values from multiple documents present in a collection to perform operations on these grouped values and return a single computed results. Now, it actually groups multiple documents which applies an aggregation operation, and it is basically returning us the particular value that we want from that operation. Now, there are various ways on how you can perform aggregation. We have three different ways of carrying the aggregation process in MongoDB. The first one is aggregation pipeline. Next, we have MapReduce, and finally, we have single purpose aggregation. So you can further explain each of these aggregation depending upon the interviewer's preference. So basically, aggregation process in MongoDB is modeled on the concepts of data processing pipeline. So multiple documents enter the pipeline, and then these documents are being transformed into the aggregated results. Next, we have the MapReduce. As the name suggests, it has two operations, which is mapping and then reducing that operation. So it will map each document and process along with one or more objects for each document, and reduce phase in which output of map operations are being combined together. And finally, we have single purpose aggregation operation, where these operations aggregate all the documents from a single collection in MongoDB. Now, even though they provide a simple access to the basic aggregation operations, they lack the flexibility that are being provided by the aggregation pipeline and MapReduce operation. So these are the three aggregation pipeline method which they go through. First is basically the map stage, which will filter the records or the documents we need to work with. And next it performs the group operation, which basically is the aggregation. And finally, it will sort the data. So it will sort the resulting documents the way we require, that is in ascending and descending order. Now, just like any other operations given by aggregation in MongoDB, we also have 5 different types of operations that we can perform, which is sum, which will add up the values of every document. Next, we have average, which will compute the average value of every document. And we have min, which returns a minimum value from a document. And we have max, which will return the maximum value within a collection. And finally, we have push, which will add the value to an array in the document. Moving on to the next question, what is meant by ID field in MongoDB? ID is the field that uniquely identifies a document present in the MongoDB collection. So when you are trying to insert a new document into the database, MongoDB will automatically create a unique ID field which will have a unique value to its name. Now, by default, MongoDB creates a unique index on the ID field during the creation of any collection. And the ID field is always the first field in the document. And if the server receives a document that does not have any ID field first, then the server will move the field to the beginning. And also, ID field can be avoided in the document that you want to return by setting the value of the ID field as 0 in the query. So what are some utilities for backup and restoring in MongoDB? Now, by default, MongoDB shell does not include any import, export of data, or even duplication or retrieval of data from other applications. But however, MongoDB provides the utilities and database tools to take backup and perform the restore operations. Now, mainly we have four type of backup and restoring options, which are Mongo import, Mongo export, Mongo dump, and Mongo restore. So you can use one of these utilities like Mongo dump, import, export, and restore to move your data in and out of your MongoDB database. Now, the most commonly used are Mongo dump and Mongo restore. The Mongo dump utility creates a binary backup, of a MongoDB database. The Mongo dump tool is the preferred method of dumping data from your source MongoDB deployment. And if you're trying to restore the data that you have basically deleted or dumped, you can use the Mongo restore in order to fetch back the data that you have dumped. So the next question is, can you explain about MapReduce process in MongoDB? MapReduce is basically a data processing paradigm for condensing large volumes of data into useful aggregated results. So basically, MongoDB provides the MapReduce feature for only aggregation purposes. And generally, there are two phases of the MapReduce, as you can see in the name, which is mapping and reducing. So in the first phase, each document is processed and emits common and redundant part of the document to pass a unique record for the next phase. And in the next phase, all the unique part gets together and aggregated to produce a single result. And finally, we have a query. Here we'll pass the query to filter the resultant set. So with the help of MapReduce, user can perform sorting, filtering, and document modification as per their need. So moving on to the next question, which is, how does MongoDB ensure high availability of data? In general, high availability refers to the improvement of a system or any application's availability by minimizing the downtime caused by routine maintenance or any hardware related issues. So MongoDB automatically stores copy sets and multiple copies of data distributed across servers and data centers. Now, in general, MongoDB is one such database which can provide high availability for the users by using features like replication and sharding. Now in replication, the replica sets help prevent website downtime using native duplication and automatic failures. Now MongoDB has a great support for high availability without no thought through replication set, but replica set is not enough for a production ready system. That is, it requires a bit of planning in order to deploy this. So sometimes it might be an issue, but in most of the cases, if the system crashes or the hardware or software faces any issues, MongoDB helps you recover and backup your data in the system. So the next question is, what is the role of profiler in MongoDB? Now, so far we have discussed some of the basic to moderate level questions, guys. Now, from here on, you will find some practical as well as advanced level questions. So you might need to focus a little bit. And even if you're not confident and if you don't know the answer which we are discussing now, you can directly tell to the recruiter or the interviewer that you do not know the answer, but you hope that you have an idea on this and you can work on that and you can get back to him. So again, let's get back to the question, which is, what is the role of profiler in MongoDB? Now, database profiler is used to collect information regarding the queries which are executed on an individual database instance. So basically, this profiler in MongoDB database allows you to collect performance data about operations occurring on a MongoDB instance. The next question is, can we use regular expressions in MongoDB? Now in SQL, we do have regular expressions where we write a query to find certain patterns that are present in our database table, right? In a similar way, regular expressions are also used to match patterns in a document, just like finding a pattern in an SQL tables. So a regular expression basically provides patterns or sequence of characters for matching and defining a search pattern. And also retrieving an unidentified field using a certain pattern becomes easily within a document. And querying a database in order to find a smaller subset of data within a collection we can use regular expression. So regex operator in MongoDB provides regular expression capabilities from pattern matching strings in the queries. And the syntax is followed as db.collectionName.find, mention the field name and mention the regex keyword and mention the pattern. Now the pattern can be of any of your choice. So the next question is, how do you search for documents in which a specific field has one or more values? Now you can say this is a bit of practical question, guys. The interviewer wants to know whether you are not whether or not you are comfortable and have an idea of using various operators in MongoDB. So you can use the db.collectionFind operation and also use a query operator which is $in order to specify the field and the values that you want to retrieve or you want to search for in a document. So for example, I have given an example which says that in order to return all employees whose title is product manager or executive director, in such case the query would be db.employees.find, mention the field which is title, mention the in which is a query operator here, mention the product manager and executive director which we are trying to find. So if there is any record or the person who is associated with this title of product manager or executive director, it will retrieve the record. Now we have a person name whose first name is Rahul and last name is Kumar, whose age is 29 and title is product manager. So this is how you can search for a document with a specific field which has one or more values. So the next question is, which command are used to insert single and multiple documents into a collection? Now we basically have two types of commands, which is db.collection.insert1, which will insert a single document into a MongoDB collection and it returns a document containing the inserted documents ID field. And next we have the same command but the keyword changes, which is insert many, which is insert a single or even multiple records into a MongoDB collection. Again, it returns a document containing each inserted document's ID. Well, the next question is, what is the difference between all and in operator in MongoDB? Now, both all and in operator are used to filter documents in a sub-array based on a conditional statement. So, but there are some differences or subtle differences between all and in operator. Now, when I talk about all operator retrieves all the documents which contains the subset of the value we pass, and this subset might be in any order. But whereas in operator retrieves all the documents which contains the either of the values we pass. Moving on, what is the next question is, both writes and reads become faster when you add more slaves to replica set. Is the statement true or false? Explain the reason. Well, the statement is false. Now a replica set can only have a primary at any particular time, that is having a one master with other nodes, the secondary nodes being slaves. So all write operations are performed only on the master node. Read operations on the other hand can be performed on any instance which can be a slave or a master node. So as a result, adding more slaves to a replica set accelerates only reads operation and not the writes operation. So the statement is not valid and it is a false statement. We cannot write and read both operation when you add more slave to replica set. The next question is, what is shard key, and mention the components of MongoDB sharded cluster. Now what is a shard key? Shard key is used by MongoDB to distribute the documents of a collection across shards. Now on sharding a MongoDB dataset, a shard key is automatically created by default. So the shard key can be in the form of indexed field or indexed compound fields that will be used to distribute the data among the shards. Generally, the shard key is used to distribute the MongoDB's collections documents across all the shards where the key consists of a single field or multiple fields in every document. Now the idea is to have multiple replica set with multiple primaries, which would basically divide data and load it among themselves. And each of these replica set is called a shard. Shard basically has three components, which is basically shard, Mongoose, and config server. All this together comprises of a MongoDB sharded cluster. Now when I talk about shard, what is a shard? Shard contains a subset of the sharded data. Okay. A shard is basically a single MongoDB server or a replica set that stores a partition of the application data that you have divided. Now next we have the Mongo's. Mongo's router it is a router of operations. Now because each shard contains only part of the cluster data, you need something to route operations to the appropriate shards. That's where Mongo's comes in. The Mongo's process is a router that directs all the reads, writes and commands to the appropriate shard. In this way, Mongo's provides client with a single point of contact with the cluster. And finally, we have config servers. Now, Mongo's process are basically durable, should be durable. That means it must be in a position to store the metadata in order to properly manage the cluster, right? Which we have formed with the shard key. So that's the job of the config server. This metadata includes the cluster configuration, the location of each database, collection, and the particular range of data therein. So this is what basically shard key is, and multiple components that are included in the MongoDB sharded cluster. So moving on to the next question, which is the join clause is a key feature of relational database systems. What is the MongoDB equivalent, if any, and are there any limitations? Now, whenever we hear about joins, we have like different operations like inner join, outer join, left join, and cross join. So similarly, we have a question here. That means if we talk about NoSQL, that means we do not have no joins. That means we do have joins or we do not have joins. That's the main question. But the thing is, we have a join equivalent in MongoDB also, which is the lookup operator, which is a significant disadvantage. That is, it does not work in sharded collection, right? So it's worth noting that rather than looking for a direct equivalent to join, MongoDB developers often simply denormalize the data, and which eliminates the need for a join, operation in a MongoDB database. So in a nutshell, you can say it performs an outer join to a collection in the same database to filter the documents from the joined collection for processing. Now the lookup operator adds a new array field to each input document, and this new array field contains the matching documents from the joined collection. So the next question is, mention some pros and cons of normalizing data in MongoDB database. Now, normalizing data is a key factor in relational database, but what about MongoDB? Now, updated documents is fast for normalized data, and it is relatively slower for denormalized data. Well, on the other hand, reading documents is fast in denormalized data and slow for normalized data. So denormalized data is hard to keep in sync and takes up more space. So RDBMS generally have this organic support for normalization and allow data to be managed as a separate entity, whereas NoSQL DBMSs like MongoDB do not have this active support for normalization. So the next question is, what are the advantages of using MongoDB? Now there are various advantages of using MongoDB. For example, it is an open source DB, that is, it is readily available for everyone to download and perform the operations right away. And it is also easy to use. The syntax is also user friendly, just like SQL. It is also highly flexible, which allows you to store and work on different data types and allows you to store unstructured data of different types in one or more documents. And the security is also a paramount feature for any user, right? So MongoDB provides advanced security features as well. And we also talked about high availability in our previous question. And it also has reliable indexing for a faster retrieval of data. It has a flexible schema design, unlike the predefined schema in relational databases. So this flexible or the dynamic schema design allows you to meet the ever-changing conditions of the big data applications, with a vast amount of data that is being incorporated into the documents. You can have a better edge on the data if you're working on large-scale applications. Then MongoDB can be a great choice for you. With all this, it also gives you high performance, which is another key feature of MongoDB and one of its greatest advantage of a NoSQL database. And that brings us to the last question of our interview question, which is, what are some applications of MongoDB? Now, MongoDB, being a NoSQL database, is widely popular in many sectors nowadays. And some of the major applications or real-time use case of MongoDB is it is used in IoT, which is Internet of Things. With the world rapidly advancing in in technology, IoT plays a crucial role, and it is important that we as a user have this intention to store the data and have that data protected in any sense. Now the data is only getting larger and larger, and we also heard this phrase that data is the new oil. So in the coming years, the data is exceptionally going to rise, and we need MongoDBs to store this huge volumes of data into our databases, right? So it is one of the applications of MongoDB. And we also have mobile applications, and in order to perform real-time analysis. And we also have it is also used in catalog management, content management, and for product management and various other sectors as well. Now companies also like to use NoSQL databases because of its flexible design, and the need of storing data without any predefined schema makes it a best NoSQL database. Like companies like eBay, Shutterfly, New York Times, Verizon, and many other big companies use MongoDB nowadays. And also the one of the real life application or use cases, the best example you can give is Aadhaar card, which is India's unique identification, which is based on identifying a person's identity. So the Aadhaar uses MongoDB to store this massive amounts of demographic and biometric data of over more than 1.5 billion Indian users. So Aadhaar uses MongoDB in order to store the images, QR code details, the personal details of the user in its database. So these were some of the applications of MongoDB. And well, with that, we have come to the end of today's session, guys. I hope we have covered pretty much the most important questions that might be asked in your next interview on MongoDB. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the questions we have discussed in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. If you want us to cover some more important questions, let us know in the comment section below, and we'll make a part 2 of this MongoDB interview question series. And if you want to learn more about MongoDB, we also have a dedicated playlist on our channel. So make sure you subscribe to our channel and hit that bell icon to never miss an update from us, so that you keep track of all the videos that we publish on our channel. So make sure you check out the MongoDB topics on our channel. We have a dedicated playlist. We'll leave the link in the description below. We'll see you guys in the next videos. Until next time, stay safe and keep coding.